Depending on the material thickness you're going to be cutting, you will need to change both the current and potentially the shield and nozzle to the arrangement. So the shield is the outer part here, nozzle is internal, the electrode, that stays the same. So depending upon the current range we're going to be cutting at, so up to 45 amps is, I would say, for a range, say for 3mm. 65 amps, you can see the credentials here as well in terms of the travel speed and the amperages it's going to be set at. So we move up to 65 amps, you can see straight away that the material ranges and the currents increases again. So again, up to about 6 to 8mm. 85 amps, I would say 8 to 10mm, and then further on from there, 105 amps, the range then I would be looking at cutting more towards 12 up to about 25mm. The only difference being is obviously as you change the thickness of the material, so if we change, we're on 105 amps at the moment, we change the thickness of the material and we change it say to 10mm, for argument's sake, then you'll see it drops down here, so it will reset the speed at which it's going to travel at, the curve that we're going to get from that, any of the component parts in terms of nozzle sizes we need, the actual arc voltage, the current, the cut height for the nozzle, and the piercing height as well. So to change these nozzles, what we're going to do is we're going to disassemble the current component parts on there, check to see what size are currently in place, and then we're going to change them to the ones we want that are going to match the thickness of the material and the program setting we've got it on, and then we're going to adjust the hypertherm machine to set the current range that needs to be set to match the component parts on here. So what we're going to do is we'll take the whole thing off, so we're going to take the whole section of the head off itself, and within that it's made up of our outer shield, our inner nozzle that comes out from the inside, and our electrode. So our electrode there, we're looking to make sure that there's no massive damage to the inside there, isn't no erosion on there, which is fine. The nozzle itself, you can see there's no elongation on the actual nozzle, the hole itself, it's still nice and round, with no pitting or chunks taken out of it. And again, we're making sure that the outer nozzle is in good condition. And all these holes, when we look down the inside of this, we can see all these little holes just to make sure they're all nice and clear, there's no blockages on them. Numbers on there, so this one says 45 to 85 amps, which is perfect in terms of what we're going to be looking at. And this one here says 65 amps, which is what we wanted to set the machine up on in the first place. So we've got a 65 amp nozzle, electrode is the correct one that matches that as well, and we've got a 45 to 85 amp shield, which is within the range for this particular type of nozzle. So what we're going to do then is we're going to screw the nozzle back on the outside like so. Just nip it up, not too tight, just so it's tight, and we're going to drop the nozzle with the electrode in the back down the inside, so it locates on the inside like so, and then we're going to push that back up over the top and screw that on like so. Again, just making sure that it's just nipped up tight. And then on our hypertherm unit, which is this unit here, what we're going to be doing, it's already currently set on 65 amps, but you can see this red light's on here, so there's a switch on the nozzle head itself, and basically when we unscrewed it, it forces this switch to turn on. So we just need to reset that, so we're just going to turn the machine on at the back, off should I say, and then turn it back on again, and we've now reset that. So we're now functioning correctly. We've got no air lights on, so we know that we've got the correct gas pressure or air pressure for the machine. The functions are working correctly in terms of everything's in sync with itself. So now we're ready to continue with the cut.